there's some concern I have as to whether this is feasible at some level, technically, let alone politically. But basically, what I'd be interested in is getting a API for a storage engine. Welcome. I'd be interested in getting a API for a storage engine that can work with a bunch of different storage engines. So the ones that I sort of know enough about to be able to pontificate on at all are Berkeley DB and the Tokatek storage engine. I know a little bit about InnoDB. And I'd like to work with a bunch of different databases like MySQL and PostgreSQL and Ingress. And part of this is just selfishness, is that if there were an API that I could code to that the other half of this was done, then I could do it once and run in lots of places. So the other issues that I have problems with the MySQL storage engine API, which is sort of the thing that inspires all this, is that there's no specification for the MySQL handlerton, there's no test suite. The reference implementations that they have, such as they are incomplete, so you can't sort of use one of those to figure out how to do everything that you would like to do. And so that's, this is the selfish picture. This is the big O picture. What's wrong with the current setup is that I have to implement if there's 3 databases, I have to do 3 ports. So does Berkeley DB, and so does InnoDB. And if there's N storage engines, N databases and M storage engines, then there's N times M total work, which is unattractive as that proliferates. And I'd rather see a world in which the world only has to do N plus M work. So each storage engine has to code to the API, and each database has to code to the API. And the good thing about it is each vendor only has to do 1 port, right? That's the vision. It's possible? I don't know. So here's a picture of how things might go in if one were to try to make it all work together. So this is not much different from the current real-world situations. Sort of the stack here is that the databases are at the top. There's a bunch of the stuff that doesn't work. There's a path in here that actually does work, which is, for example, Berkeley DB and TokuDB are down here. There's a header file that Berkeley DB provides, which is essentially the same header file that we use. And then there's a header file that we talk to the MySQL handler with, and it's almost the same as this header file. So there's a little shim in here to make that plug together, and perhaps a little shim in there that's almost trivial. And then there's the MySQL handlerton, and this is GPL. So if you download our source tarball, everything above this line is included in the source, and the things below here are not in our tarball. So there's this handlerton, which is handler.cc, and then that codes to an API which is sort of instantiated by handler.h, and then there's MySQL. Another path you see is InnoDB, which has its header file, and the shim here is essentially a no-op, and there's a handler for that, and that goes up to MySQL. This API up here is a relational store, whereas this API is a key value store. So here we're storing byte strings, which are keys, and have to have some comparison function. Up here, this API understands that there are rows and there's columns, and that the columns have types that are integer or varchar. It understands collation orders. It understands that there's an index that comprises these 3 columns. So that API is a more sophisticated, higher level API than this one, and that's where InnoDB goes up to. So in some sense, this handler has to do less work in InnoDB because the semantic gap is less. So there's some redundant work going on here because we have to do some of the work for converting things to rows and columns and encoding rows, and InnoDB is doing that work down inside InnoDB. And I would like it if there was less of that, but as far as I can tell, there's a whole bunch of storage engines that really are key value stores, and so something needs to be done. So I'm envisioning an adapter in here that converts relational to key value store, and that can be open source, and do that only once for all the key value stores. And then also I envision sort of maybe we can make that work where Ingress and PostgreSQL can be made to talk to something. Yeah?
So what from this, what exists, what code exists today from this?
Well, this stuff exists. We've got one of these running. This exists. There's nothing. This doesn't exist. Some path through here exists, and none of that exists.
Okay.
Although it's, you know, the path through here isn't sort of divided up into and this API and this API are still unspecified at some level.
So I guess I don't get why you have that relational to KV adapter box and you have MySQL KV handle.cc. Is relational to KV adapter generic across database servers?
Yeah, so the idea is that for now, it's sort of, this work and this work have been done, right?
Okay.
So we have a handler that knows how to talk to a relational store and one that knows how to talk to a key value store. So the fact that there's redundant work, well, it's a sunk cost. Maybe, you know, maybe we don't want to maintain it forever, but it's not so bad. But if we want to go and expand up into these worlds, I don't want to do this, the sort of the relational part again and again and again for each of those things.
Okay.
Does that make sense?
Okay.
So that's the vision, and at some level, that's where the intellectual part of the talk ends, and I can talk about some specific things, and then I'd like to just start talking about whether the dream is impossible or whatever. So one of the things is, I've been working on writing a spec for this API. I don't have that ready to show you, although I could show it to you anyway, but it's not really ready. But I'm happy to share it, but why waste your time? It's specified in C because too many pieces are in C. So Ingress and Postgres are in C, and TokuDB is in C, and Berkeley DB is in C. So that means that I'm stuck with C.
Have you had the pleasure of reading Ingress source code? I have.
I have read all of the source code. Well, I've skimmed all the source code. Everybody says this about everything, right? It's like, have you looked at MySQL source code? Have you looked at Postgres source code? It's like, everybody says this about all the codes. I don't know whether, I think databases are hard. So, I don't know, do you all know the Berkeley DB API? So I'll just go over and sort of, there's a style of object orientation that they came up with that I kind of like. Is that even though they're programming in C, you kind of still get to do object-oriented stuff. And what they do is they have these objects that they call handles, and so you create one of these handles. So this is a call to fill in this DB, which is a pointer to a struct. And then the struct has fields like open, which is a function, a pointer to a function, and put, which is a pointer to a function. So open changes this handle to do an open database, and put inserts a key value pair into the database, and close and get those operations and so forth. And so there's very few names in the global namespace, right? The global namespace includes this name and at link time, right? The library has to export that symbol, but it doesn't have to export a symbol corresponding to DB arrow open. So there's very few names in the namespace. And if you were to implement something that actually programmed to the same API that used different functions for all those, which is what we did, then the two things can actually coexist. If you call DB create to fill in a DB, you get that. If you call TokuDB create, you get a compatible structure if you've compiled it with the same header files and everything works. At least that used to work. I don't know if I actually test it anymore because it didn't seem to be worth to maintain. So this is what the BDB style objects work. There's a structure, and this is something my capital variable type defs are always pointers to, so I would put a star in there, but yeah, it's an opaque type. And after that, so you have a struct full of all these things, and then open, close, and put. Another thing I don't like about Berkeley DB is the DBTs. So this is the way they return values. Is they have these structs called DBTs that you can return values in. And DBT apparently stands for database thing. They couldn't think of a good name for it, so that's what they named it. And database things are slow and tricky. So if I want to do a get of the first item, and I've kind of simplified this, really if you want to get the first item out of a database, you have to create a cursor, and then you can do the cursor first operation. But I'll assume that there's an operation that says, give me the first item of the database for simplicity. Well, you have to set up, declare these two keys, and you have to initialize them to zeros, and then you have to pass their addresses in. And then after you get the result back, you can use the values. These things contain a pointer to some data. You can only use that until you call, if you call another Berkeley DB API call, then those pointers become invalid because it may reuse the same memory again for whatever purposes. So it's really quite tricky to use this, and so you can't actually do this in a multi-threaded environment because it's not multi-thread safe. So then there's another mode, I wonder if I wrote it here. Yeah, where you say, well, don't allocate static memory, malloc something and give it down all of it. So here we have to initialize the thing, and we have to tell the flags. And as soon as you see a data structure with flags in it, my head starts hurting because trying to understand it, when we implemented DBTs, it's like there's this whole bunch of code to implement this semantics, and it's nuts. So then you say, okay, malloc me something, and so it mallocs it, and now I own the thing that got returned, and I have to remember to free it. And that's sort of painful. And there's a whole copy of the whole key and value get copied into this thing in addition to the malloc with any of the interfaces, whether you let Berkeley DB manage the memory or you give it, I manage the memory. There's a copy. And in MySQL, often I find a situation where I'm doing a select sum x from table. So there's 4 bytes in there that I care about. And the DBT copies all 1,000 bytes of the row into the DBT, and then my code goes and pulls out the 4. And so there's a big copy in there, which is actually a performance hit that we see when we're doing range queries.
So this model is there are no columns.
Well, it's because it's a key value store.
Yeah, so
right.
You're getting the value.
So then I could do something where I allocate the memory and don't even use malloc, right? So I figure out, I know the rows are less than 100 bytes, so I can fill it in. This is all the magic to fill in the thing, and finally I do my get. And now I own the data, and I don't have to remember to deallocate it because it's it's an auto variable in my stack. But I still have to copy the data out, and that's expensive. So what we actually did is we changed the API slightly to do a callback function. So instead of passing in a DBT, we pass in a function that says call this function, and the function's prototype is pass, the pointer to the key is here, the length of the key, the pointer to the value is here, the length of the value, and then we pass in an extra void star which gets passed to us so that we can remember this is the closure that we need to do the rest of the calculation. And this pointers actually should be declared const char because this code's not allowed to modify them. These pointers can point directly into the data structure that the underlying storage engine is using to buffer data. And the lifetime of that is when this function returns, those pointers aren't valid anymore. But while that function's running, those pointers are pinned down and they're good. And that lets this code not avoid that whole big copy of the 1,000 bytes. It can just go and fetch out the 4 bytes that it wants because this function is implemented sort of up in the Handlerton layer is where that function comes from. And at that layer, it knows how to parse, it knows the mapping from a row into the byte string that represents a row. So that turns out to be much simpler and faster from my perspective. I run into some resistance on this because lots of people don't like callback functions. And there are some trickinesses that you have to watch out with callback functions. For example, the callback function can't do a callback into the Berkeley DB layer because that leads to deadlock. Basically, this layer, the Berkeley DB layer, contains some locks or pins or something on this memory to keep it from moving while the function's running. And so if I try calling back in, you can run into some trouble unless you're very careful. And we're not careful enough, so you just declared you can't call back. But I like basically passing functions around instead of data. So you can't invoke a DB function. And one of the things that we do when we're fetching multiple values out is we just pass the function in and say, well, call the function on the next n items. So it just calls the function, calls the function, calls the function. And then there's some arguments here that say whether or not, how many times did you actually call it? Because if you run off the end, you may get a short number of calls, and I didn't specify that. I haven't specified error codes or unusual cases here, but that's basically, turns out to be much faster in my experience than the standard Berkeley DB API, which is actually quite difficult to do multiple key fetches with. Okay, well, if we're going to really do this, we need a relational API, and I have nothing to say about that of any intelligence right now. The deliverables for this project are a specification, and I'm implementing it in NoWeb so that the specification actually emits a header file. So the header, it's a literate programming style, so that I actually end up with a header file that comes out. And GPL reference implementations for the various shins. So for example, the piece that take you from this spec to Berkeley DB is part of the contribution. A GPL reference implementation of the MySQL handler, which essentially we've published. A reference implementation for the relational part, which I have basically made no progress on, and and the handler for the relational thing. So that's that's sort of what I'm working on in my part-time, and I don't know whether it's a reasonable way to spend my time, but so so is this, what do you think? Is this a bad way to spend time?
I'd love for someone to give me a rational interface to a data handler. And right now, the one that exists, I just shudder whenever I have to deal with it.
So you're talking about the MySQL
Yes.
interface. So how do you feel about the InnoDB API, the embedded API?
Well, it's relational rather than key value. It's much cleaner. I could live with that too.
Is it well enough documented?
It was documented. So I read the document. I didn't read the source code. From the document, they didn't have a full description for every function, but it was certainly.
So it's it's a reasonably good start, though.
Yes.
So it's coded up so that the functions are like, all the functions are just functions, right? They, InnoDB underbar foo or something.
They're not using 12x, but they are also allowing you to. There was column awareness in it. I'm not sure if they have the ability to select a few columns with a cursor, or if you just get all columns.
So as I understand it, that API is when you want to build a table, you build a data structure that says, it's an int named X, and then a varchar of length 20 named Y. You basically build up a data structure like that, and then you say, now create this thing, and maybe you pass in a list of descriptors for the indexes at some point. So I like that API too. I would rather, but I don't want to do the translation from, I don't want to be paying that price multiple times as I implement that for other databases. So, okay, so does anybody know anything about these other databases, whether this is going to be possible?
Postgres?
Yeah.
I think my feeling is that Postgres has intimate knowledge of the properties of the storage layer pushed up into the SQL layer. I mean, for example, there's no index-only scanning because row visibility is in the heap table, not in the index. So when you do the index scan, and you pick up things from the index, to figure out whether you can actually see that entry in your transaction, you need to go back to the base table. The optimizer, I assume, takes that into account when costing indexes paths.
So they don't have covering indexes? Is that what you're
So
saying?
they do have covering indexes, but to determine if the index entry that you encounter is visible to your transaction.
I see.
Based on the lifetime of that. You have to go back to the base row to get that.
But that's because of their MVCC.
The way they do it, yes. And Falcon was going to do the same. Although we don't have to worry about it. Because Falcon is not going to be a product of that. So that optimizer must have some knowledge of that when doing costing and access. So I guess one question is, are you also going to have methods for optimizer costing if that's required?
Well, if I think that makes sense, is that they should be, those methods are in the MySQL layer.
Yes,
Berkeley-
but with these obscure names.
Yeah, and Berkeley DB has optimizer cost hooks,
Okay.
which are basically, you can ask for things like, how many keys are between, roughly, how many given a range, how many pages will I touch roughly?
Okay.
That's the kind of thing Berkeley DB can give you.
And you also need hooks for XA.
Yes, so we haven't worked on XA, but we need hooks for XA, which Berkeley DB has. Berkeley DB has XA.
And the crash recovery of XA.
Yes, so Berkeley DB has XA,
Okay.
and so my model on that is, since I don't know better, I might as well use their API for those things like XA. And it seems like a perfectly good implementation of XA. I can't think of anything better. I have read it; it makes sense to me. So
right now with the handler.h, there's no chance of me taking on a hobby project of hacking. I'll hack on InnoDB, but starting a storage engine, just trying things out, there's no chance I will do that with the existing code.
would there be a better chance if you were given the, if you said, well, just
With this, I could do
implement Berkeley DB API
Then I could do it.
or the InnoDB API? So those are your two choices. That
Berkeley DB API makes it a little bit easier.
it's easier to get started with Berkeley DB API, right? Which is another reason why I kind of liked having that adapter layer in there, is that somebody who's just trying to get started kind of gives it's so much easier to deal with when you're trying to get something going. Okay, well, so maybe in the MySQL world, it's worth playing around with this just to make it easier for people to proceed. There, lots of people that I talk to sort of say, what's wrong with what we've got?
That's why what we have is not changing and improving.
Yeah.
I mean, where are rows passed on it? Table handler has this array that can have 3 elements, and tell me which, I'm sure Sergey, some of the core team, can tell me when each of those 3 elements in the array are valid on insert, update, delete, and search. But it's not written down anywhere. I think it's the row field. I've had to maintain custom storage engines. Never enjoyed it.
So is the Berkeley DB API good enough for all the custom storage engines you've worked on?
Yeah, that would have worked. Would have made life easier for the authors.
Because the one possibility is that there's some storage engines out there that are just too wacko to fit into this model. But
The other thing is we need condition push down,
yes.
batch key access.
So I showed you the batch key access at the BDB layer. Or the actual BDB, Berkeley DB's batch key access.
Well, batch key access is here are the keys. So this is a range. Isn't this a range scan?
This is a range, yeah.
So batch key access is here are 10 keys. Give me rows for them. You can do it. You can do it in a Berkeley DB-like manner, but it's not in Berkeley DB.
Yeah, so that one isn't, but yeah, so range queries. So Berkeley DB does it with DBTs, where they give where the DBT turns into an array of DBTs or something. It's crazy. It's too hard to use.
But actually, I don't know if this interface has to expose batch key. It's just the upper half of the caller will say, here's 10 keys. At that point, this can iterate on them, or if it's smart, if it's higher performance, could potentially do the fetches in parallel. And certainly Berkeley DB would not support things running in the same transaction context in parallel.
Yeah, well, we will be. With that API, we're expecting to support parallel operations in the same transaction.
Okay, but you don't have to put that in the API here.
Yeah.
This is up to you. You're given the keys. You do what you want to do. Just give me the data back from them.
Right. Okay. Well, so you're much more, you make me feel much more optimistic than anybody else I've talked to here.
See, here's the thing. I think this is a great thing for the community over time. Does it help you get your business done? I don't know, but I'm thrilled that you.
That's a different problem. But,
Well,
I'm part-time at MIT, so maybe I just do this, with my academic hat on. Instead of, so that gives me a bunch of freedom to do things. I sort of have, Google has their 20%. I have my 20% is just MIT.
20% is a myth.
Yeah.
Rule of myth.
It's a great myth, though.
It's 20% if you consider Sunday to be 1/5 of your week, and the other 6 days are the other 4/5 of your week.
Well, in my case, since I'm spending regret money, I have to actually work for my 20% on my 20% stuff. So I do things like terabyte sorts and silk contests, and maybe I'll work on this. Okay, well, I will blog about it when I actually have a spec that is written and that is even a beginning. I'd really hoped to have spent 5 days on it and have it ready to show.
And so the code that implements mapping of MySQL to this will be GPL?
Yeah.
Okay.
And basically it'll be a variant of today's the TokuDB handler, which is a Berkeley DB handler with mostly with a bunch of bugs fixed.
Okay.
Is GPL, and it's supposed to be on the website. When I tried downloading it yesterday, the web link was broken.
Quick question: what's the rationale for using GPL for the reference implementation? Because if you're talking about maybe integrating into Postgres, that's not going to work. Or at least, I mean, you the two licenses are not really compatible.
Well, the GPL people think that the Berkeley license is compatible with, in the sense that you can distribute code that is compiled together, and you can distribute all the source code, and it's fine. It means that incompatibility is whether if you want to fork it and close source it, then the fact that the GPL pieces you can't sort of take through that wormhole with you.
Basically, you're pulling the GPL reference implementation into Postgres, thereby making Postgres GPL.
Well, if you want this piece. Now, I'm not completely wedded to, you wouldn't have to do it this way. Part of it is that the specification itself, does it make sense to make the reference implementation be available under another license? I'm open to that possibility. Does it?
I mean, we GPL our stuff, but when you talk about reference
At where?
we have an in-memory data engine.
Who are you?
I'm Felix. My name is Felix.
Felix, and
we have a project called BlackRay.
and who's we? I can't read your thing.
It's a project called BlackRay. It's
Black. I'm sorry, this thing is blowing in my ear.
We have a project called BlackRay. It's an in-memory database which we developed for commercial client. It's GPL, which is fine for me, but when it comes to reference implementation, anything like this, I mean, we're moving away from GPL for what we do, because I guess we really prefer now stuff under Apache. Just use business to that. Now, with the reference implementation, one of the reasons we didn't implement the MySQL protocol into Apache is because the documentation of MySQL is GPL. So if I base my implementation on the GPL documents, opinion is that then your implementation will have to be
Implementation of what?
If you use any piece of code for reference implementation,
So you're talking about the storage engine, you're talking about the Hamilton part, or?
I'm talking about if you have the reference implementation, it's GPL. You will not be able to derive any code that's not GPL from it. And that's going to be a problem for the Postgres guys.
Yeah, so it may make sense for certain pieces of these to not be GPL. Maybe all of it, but I could well imagine that, going back to this picture, this thing is GPL because it's got to go with MySQL, but maybe, this thing shouldn't be GPL if anybody implements it, right? That would make no sense. This API is an insulating layer because below this you can consider this to be if it becomes a standard API, then basically this GPL system, the GPL2 there's the system library exemption, and in GPL3 there's a standard API exemption. So essentially it doesn't matter what happens going across a standard API. You don't have to have compatible licenses across it, as long as there is some, as far as the GPL is concerned, as long as there's some API some implementation, for example, that's open source in GPL3. So, my feeling about this is that layer actually becomes a boundary that lets you hook up GPL code to Postgres without a problem. So, to the extent that strategy really works, I think that it's advantageous to. This is the strategy we're following. We don't actually have an agreement with Sun at Tokatech because we couldn't come to an agreement with them. We tried. They tried. Didn't work. So basically, the Berkeley DB API is that boundary between us that lets we ship TokuDB and we ship codes that compile to the TokuDB version of Berkeley DB API, sort of as a proof that it has use outside of MySQL, which some people think makes a difference for making the case that you're not violating the GPL when you're distributing something in closed source form. So does that make sense to you? It's like, does it seem to you that it matters which implementation this is? Maybe not. I could imagine somebody doing their BSD up to here and their GPL through that, between those two interfaces, and then closed source through there, right? That works for me. Okay.
Thank you.